Hello, dear students. In the last chapter of Polynomial Part 1, we studied about what is the meaning of polynomial, what are the different types of polynomials like monomial, binomial, trinomial, and based on the degree we classified polynomial into a linear polynomial, quadratic polynomial, or a cubic polynomial. And we also studied the values of a polynomial. So value of a polynomial is the value that we get by replacing variable with a real number. And we also studied about the zero of the polynomial, which is a very important concept. So arithmetically, zero of a polynomial means the value, the real number, which if we replace variable in the polynomial, then we get a value 0. So if we have an equation, so let us take this a simple linear polynomial. So what will be the 0? It will be the value which gives the value of this equation as 0. So we get 3x plus 9 equals 0. That means x is equal to minus 3. So if we replace this value minus 3, if we replace x by minus 3, we will get px is equal to 0. So minus 3 is the 0 of this polynomial. So now we will study what does this 0 means geometrically. Geometrically means, see, we have this equation, whether it is a linear, binomial, I mean linear, quadratic or cubic equation. And if we plot it on a graph, so we'll get some shape that will be either a line or any kind of curve, whether it is a parabola, hyperbola, a circle or anything. So if we plot this polynomial on a graph, so what does a plot means? See, in graph we have x-axis and y-axis. This is your x-axis and this is your y-axis. So if we take any point on this graph, it has some x value and some y value. So this is our x-axis and this is our y-axis. So values on the x-axis are known as abscissa and values on the y-axis are known as ordinate. And if you take any point on this graph, so there will be some corresponding value of x and y. This is positive, this is all values here are negative. Here we have x as positive, y as negative. Here we have x negative and y positive. These are also known as coordinates. First coordinate, second, this is third, and this is fourth. So let us now take a simple linear polynomial. Simple linear polynomial is of the form ax plus b, where a is not equal to 0. So let us take a simple binomial or a linear polynomial. It is px is equal to 2x plus 3 or y is equal to 2x plus 3. So we have replaced px by y for the purpose of graphing. So because in the coordinates we have x and y, so we have replaced px by y so that we can plot x and y on this coordinate. So if we draw y is equal to 2x plus 3, we get this straight line, which is y is equal to 2x plus 3. And how do we plot it? We consider, so here we have x and here we have y. So we put first we put value of x is equal to 0. If x is equal to 0, then y is 3. Then to draw a line we need at least 2 points. So this we have got this 1 point, x is equal to 0 and y is equal to 3, this point. We need one more point, so we place y is equal to 0 in this equation. So we get x is equal to minus 3 by 2, which is your this point. So we have got these 2 points, then we join these 2 points and we get a straight line which represent y is equal to 2x plus 3. So now if we see the value of y is equal to 0, what is the point minus 3 by 2, which lies on the x-axis. So what does geometrically 0 of this linear polynomial means? It means the point at which this line intersect x-axis. So that point is the 0 of this polynomial. So for a linear polynomial, 0 means the point at which the line intersect x-axis is the 0 of the polynomial. This is the geometrical meaning for a linear polynomial. So the line can only meet x-axis at one point. It is not impossible that this line meets x-axis on more than one point. So linear equation will have only one 0. Further, if this line is parallel to x-axis, then the line will not have any 0. And if this line coincide and with this x-axis horizontally, then it will have infinite zeros. So from this graph we understood that a linear polynomial has 0 lying at the point at which this line intersect x-axis, and this can only intersect at one point. So linear polynomial has only how many zeros? Only one zero, and that is that. So in the linear this polynomial, this equation, we put ax plus b equal to 0. So we get x equal to minus b by a. So any linear polynomial has 0, and the value of that 0 is minus b by a, where b is a constant, this one, and a is the coefficient of x. So let us take the same example as given in our NCERT book. So we take this quadratic equation y is equal to x square minus 3x minus 4, and we'll draw the graph of this equation. So we'll form this table. So we'll first take x is equal to 0. So y is equal to minus 4. Then let's take y is equal to 0. Then x is equal to minus 1. Then let us take some more numbers and find out the value. Minus 3, then take 1, then 2. We will find the corresponding values, and then we'll plot it on the coordinates or on the graph. So we have drawn this graph of y is equal to x square minus 3x minus 4. So here we see this parabola. It meets x-axis on 2 points, this point and these points. So for these points, the value of y is 0. So these 2 points are the zeros of the quadratic equation or of this polynomial. So this equation had a parabola with the mouth open on the upward side, but we can have equations either mouth opens upside or mouth open downside. So this can be another quadratic equation whose graph is like this. So what are the different possibilities? So here it meets in point 1 and in point 2. So this for this quadratic equation we again have two zeros. But we can have a graph where this parabola meets x-axis only at a single point. So this parabola or this quadratic equation will have 1 0, and it is possible that we have a quadratic equation in which the parabola or the graph of the quadratic equation doesn't touch x-axis. It can be like this, or it can be like this, or it can be like this. So all these parabola which represent different quadratic equations will not have any zero. No zero. Here we have 1 0 only. 1 0. Here we have two zeros. So depending on the quadratic equations, a quadratic polynomial can have two zeros or 1 0 or no zero, whereas linear polynomial can only have 1 0. Now let us take a cubic polynomial. So what do you see here? If the value of x approaches infinity, the y will approach infinity. If the value of x approaches minus infinity, the value of y will approach minus infinity. Whereas this was not the case with a quadratic equation. Irrespective of value of x, whether positive or negative, the value of y will remain not less than a particular value. That is, it cannot be less than minus 4. But in a cubic equation, if we have a negative number here, now so the value of y will be negative. If we have a positive number, the value of y will be positive. So the graph of this cubic equation, how will it look like? So this is how this graph, if we plot the same way by putting the various values in the table, we'll get a graph like this. This is y axis and this is our x axis. So this equation has three roots. One of the roots, clearly we can find out if y is 0, then x value of x is 0. So it passes through the origin. This is one of the value. And these 2 points where this line, this curve intersect x-axis are the other two zeros. Now what are the other possibilities? So the curve of a cubic polynomial could also be like this, where it touches, so it touches x-axis at 2 points. So these cubic equations will have two zeros. And this cubic equation has only one zero. So now can you make out, what do you make out from these three graphs? That a cubic equation either has three zeros or two zeros or 1 0. Is it possible that it doesn't have any zero? No, it is not. The reason is, I told you that as the value of x approaches infinity, positive infinity from this side, the value of y will also approach higher and higher to infinity. And if the value approaches negative, value of x approaches negative infinity to the negative, the value of y will approach negative infinity on this side. So the graph will at least intersect x-axis at one point. then only it is possible that from negative infinity to positive infinity we have the curve travels. So the cubic equation or cubic polynomial has at least one zero. So now we have understood how what does the geometrical meaning of zero means. In a linear polynomial, there is one zero, the point at which a line intersect. Quadratic equation can have two zeros or one zero or even no zero at all. Like here, no zeros. And cubic equation can have at most three zeros, not more than three. But it can have less than three. So it can have two zeros and one zero, but not but will have at least one zero. Now in the next section we will study the relationship between the coefficient of the polynomial and the zeros. We already found out in the part 1 that a linear polynomial, the zero exists at minus b by a, where b is constant and a is the coefficient of x. So for a linear polynomial, 0 and coefficients are related by the equation x is equal to so the value of x at x minus b by a is the 0 of the polynomial. Now we will find out what are the zeros and how does the zeros of a quadratic equation and a cubic equation or cubic polynomial relate. That will learn in our third part of the video.